These days, more and more branches of science include quantum in their name. But what does quantum mean? A quantum is the smallest discrete unit of a phenomenon. For example, a quantum of light is a photon, and a quantum of electricity is an electron. Quantum comes from Latin and it means an amount. Now, what is quantum computing? Quantum computing is a technology that harnesses the laws of quantum mechanics in order to solve problems too complex for classical computers. These machines are very different from the classical ones that have been around for more than half a century. The most significant difference is how they deal with data. In traditional computers, information is processed using bits representing either a 0 or a 1. However, in quantum computers, the basic unit of information is called a qubit, which is used to run multidimensional quantum algorithms. You might ask yourselves, what exactly is a qubit? Well, a quantum bit is any bit made of a quantum system, usually an electron or a photon. What makes a qubit special is its ability to exist in multiple states simultaneously due to a property called superposition. This means that a qubit can represent both 0 and 1 at the same time, without being limited to just one of those states. Another important concept in quantum computing is entanglement. While qubits are entangled, the state of one qubit becomes dependent on the state of another, no matter how far apart they are. This allows for a special kind of connection between qubits, enabling them to communicate in a way that increases the computation power exponentially. By exploiting superposition and entanglement, quantum computers have the potential to solve certain types of problems much faster than any traditional computer. So when we think of qubits, we must think in terms of superposition, interference, and entanglement. However, it's important to note that quantum computing is still an emerging field, and practical quantum computers with large numbers of stable qubits are not yet widely available. Scientists and engineers are actively researching and developing this technology to unlock its full potential and overcome various challenges. In the industry, the complex problems that would require such machines can be found within the fields of cryptography, data analytics, and pattern matching. In cryptography, encryption is based on the factorization of large prime numbers, involving more than 300 integers, which poses significant challenges for traditional computers to break. However, the advent of quantum algorithms could render this decryption process relatively easy. Quantum cryptography holds the potential to enhance the safeguarding of digital lives and assets by encouraging the development of stronger protection mechanisms. In data analytics, topological analysis explores the behavior of geometric shapes in specific ways within complex datasets. Conventional computers struggle to handle such intricate datasets effectively. To address this, NASA is considering the use of quantum computing to analyze vast amounts of information about the universe and explore better and safer methods of space travel. Pattern matching is one of the best abilities that a quantum computer has over a classical computer. The ability to identify patterns within narratives and utilize them for predicting outcomes holds great value in the business world. Companies like Volkswagen use the power of quantum computers to forecast driver traffic situations up to 45 minutes in advance. Classical computers are limited in handling numerous complex road scenarios, which is where quantum computing proves advantageous. Moreover, the most relevant purpose of pattern matching in biomedical sciences is identifying how protein will fold and its implications for medicines. This is an extremely difficult task, and further research is required in the field to create more accurate models. If this brief introduction gave you a headache, I apologize, but if you are curious, nothing is impossible. To comfort you, here are what the greatest scientists said about the quantum world. Quantum mechanics makes absolutely no sense. Roger Penrose. I think I can safely say that nobody understands quantum mechanics. Richard Feynman. I do not like it, and I am sorry I ever had anything to do with it. Erwin Schrödinger. If you are not completely confused by quantum mechanics, you do not understand it. John Wheeler.